What's up, guys? What's Short Playboy coming at you? And this is another out of my research into Nikola Tesla's various systems. This is another project that about around a decade ago, I believe. By now, I had worked on and accumulated the data on for a while, and my conclusions. My conclusions on certain specific applications of the Tesla turbo machinery led to me hypothesizing something, and Jeremiah Ferwerda, who's now the sole guy behind iEnergy Supply because his partner from, I believe, London, England died, may the guy rest in peace, that's what this started out as. Ferwerda and his now deceased former colleague basically had an epiphany that I realized, like I said, around a decade prior. So, what is that epiphany, you might ask? Well, I'll get to it. The way I was thinking about doing it and applying it to the Tesla Gas Turbine concept, well, I had my own similar conclusions to the gas turbine, but the way I wanted to enact this epiphany was different. You'll see that in episode 3 when I talk about it. But basically, if you use all of Tesla's patents and failed patent applications from all over the world that he filed on the improvements of both his turbine and his fluid propulsion centrifugal pump, you understand how all of Victor Schauberger's works. You understand them all. 3, you understand how they can all be applied to this machinery. You put all that together to make a single turbine with the fluid propulsion centrifugal pump, you being the final stage of the machine, and then apply modern tech advances and modeling to the building and construction and balancing of the machines while following everything Tesla said. If you do all this, in the words of Dr. Emmett L. Brown,
you're gonna see some serious shit.
Alright, Doc Brown couldn't have said it any better. The Tesla turbine is a turbine, so you can use the same equations to solve for its power outputs across the board, and including in relation to what RPM you choose and all that stuff that you would use for any other kind of turbine. But the trickier part is to calculate the energy transfer or transformation from the fluid and its transformation into kinetic and pressure energy on the rotating discs in what's called the boundary layer effect, and how to get the most out of that. It's a little trickier in what's called the Coanda effect. Following everything that Tesla said and continuing to cross-analyze what he said with other advances in analyzing in how to analyze and calculate for the boundary layer and the Coanda effects are the first steps in doing this, and this must be followed as I said to the letter until some evidence comes up that goes against it, which is not likely to happen. At least not in our lifetimes anyway. The disc is spaced properly together. If each disc has its edge rounded or curved, will pull on the fluid, grab it, and adhere to it and sling it about. As the discs do this, they will continue to create what are called boundary layers in between the spacing of each disc. The grabbing and adhesion to the curved disc edges is called the Coanda effect. To understand this better, remember these concepts about the nature of fluids in general. Fluids, whether liquids or gases, tend to move from areas of high pressure to areas of low pressure. When air flows around a curved surface, the air pressure on the outside of the curve is greater than on the inside. This creates a force that pushes the air towards the curved surface, causing it to stick to it instead of continuing in a straight line. The fluid particles adhere to the surface due to a combination of forces acting on them. When a fluid, whether a gas or liquid, flows over a curved surface, differences in the pressure of the fluid along the surface are made, and that makes a resultant force that acts on the particles of the fluid, pushing them towards the curved surface. One of the key factors contributing to this adhesion is the fluid velocity gradient, as they call it. In the boundary layer, which is the region of fluid that is in direct contact with the surface, the fluid velocity gradually decreases from 0 at the surface itself to the free flow value. A boundary layer is a thin layer of fluid or gas that flows along a surface, such as an airplane wing. And by the way, the resulting forces that can act on the particles in the fluid, pushing them towards the curved surface, this can also be messed with by using the centripetal force to make the fluid move towards a center. So having the holes in the center of the disc the edges of the holes also be rounded and smooth is also a big thing. This decrease in velocity creates a gradient that induces a drag force on the particles, attracting them to the surface. In addition, the viscosity or resistance to shear stress and resistance to flow also plays an important role. Viscosity, again, is as I already said, resistance to flow and resistance to shear stress, and affects how layers of fluid adjacent to the surface will behave. In the presence of a curved surface, the viscosity of the fluid causes the particles in contact with the surface to stick to it, following its contour instead of separating and following a straight path. So the discs, if spaced properly together, will pull on the fluid, grab it, and as the rotor does this, will spin and swirl the fluid around and around, slinging it and gradually pull it towards the center. Again, I said this already, using what is called the centripetal force, because centripetal forces are the manifestations of the force that spirals inward towards the center of a spinning object. Centrifugal force is the opposite force that manifests as a reaction to this that goes outward and away from the spinning object. Now, there's a bit of a philosophy of science debate on why would you call this force fictitious versus why you would not, and I disagree with calling it a fictitious force, because if it was entirely fictitious, it wouldn't be usable. But there are some other reasons I have in that discussion that I think I would. Yeah, it doesn't come from an inertial frame of reference, but what does that have to do with the things, huh? What does that have to do with it? It makes zero sense to me. There's the logic is a bit lacking. It's an actual reactive force. We use it all the time. Why label it fictitious? So the so-called reasons seem pretty arbitrary to me. But that's my take on that debate. But whatever. The velocity of the disc will start making, I guess, a pulling force as a result that will cause the area to drop in pressure until it gets inside the machine where the discs are. Then the air starts getting slung around until they get grabbed by this and then get spun towards the center of the rotor before the fluid gets shot out at the opposite end of the turbine at its center, the center area, which is the exhaust port. And whatever heat energy in the fluid is passed onto the disc to keep them and the turbine rotor spinning will get used as kinetic and mechanical energies that will also keep it spinning at really fast velocities. These principles can move a heck of a lot of air or different fluids based on these principles. Right? These absolutely can move a crapper ton of air, and as well as the spacing between each disc being following what Tesla said, depending on what kind of fluid you want to work on, is important. Remember this as well. The Tesla turbine uses centripetal forces. The Tesla fluid propulsion pump uses centrifugal forces. Remember this for later. Essentially, the possible breakthrough here is once the fluid is exhausted through the turbine's middle section at the opposite side of the turbine, that's opposite to the intake port should be over here on the side. The exhaust port is on the other end, out the middle section. If I hadn't established that already. And if it's at a certain flow rate, the possible breakthrough is once it's exhausted out that exhaust port at a certain flow rate, it hasn't been quite figured out for years, it can then be pulled through by the fluid propulsion pump or the Tesla centrifugal pump at 98% plus efficiency. According to various experiments in more recent years, the velocity imparted onto the pump's disc will cause the creation of a high vacuum of 28.5 inches of mercury suction at the exhaust of the turbine. This will cause two things to happen. If you're messing with air, water vapor will condense down due to the heat energy being extracted in its one instance by whatever's causing it to condense down or get cold, or the heat energy it has in it to get dispersed away from it. 2, when the condensed water is subjected to an intense vacuum, there is still some stored heat energy of one form or another, making it have some degree of heat. It can literally do this. As you see the visual of the rather cartoony visual to demonstrate what I'm saying, the it will explode into the condensed water under high enough vacuum will explode like this, what I showed, into a cold steam if conditions are right for it and a vacuum is strong enough to make it happen. This kind of vacuum can do that. This final latent heat of evaporation liberates a majority of that stored solar heat energy. In this example, I'm using as the combo of air and water get moved around and the work extracted from them the first time, being grabbed and slung around until it's shoved through the center and out the exhaust, which finally gets work extracted from it again by being grabbed by the centrifugal impeller discs, drawing in the fluids and slinging them around until they hit the outer walls, which I think could have some diffuser tech improvements applied to them, I'm thinking anyway. So it's the final latent heat energy in the air and humidity will be converted to kinetic energy. Part of that kinetic energy will then be turned into pressurizing energy. In other words, the energy that will be used to make a fluid go up into a higher pressure, like in a conventional turbo charger or a supercharger, or in like how every engine that we drive vehicles with has a piston that comes up to squeeze air. And lastly, that'll be sent out the final exhaust port on the fluid propulsion or centrifugal pump side, which leads to cold water and air, being shot out of it, and that'll be the final exhaust product there. So basically, a fanless turbine that uses adhesion to discs and grabbing by the discs to do its job and take heat from fluid, converting the heat into kinetic energy and changes in pressure in order to keep going. The turbine turns heat into into torque through these mechanisms using centrifugal force, and the pump amplifies the airflow because it's using a centrifugal force and radial effects to pull on the vacuum, to pull a harsh ass vacuum on the exhaust of the turbine stage, which then re-expands the now explosively vaporized water or cool steam and air, compresses them, and compresses them to extract the energy, the heat energy from just that latent heat of evaporating, to do that second heat extraction. So the converting of humidity and ambient air, stored heat energies into cold steam and cold air, you get potentially you could potentially build an ambient heat engine that actually can extract the solar heat energy that's in the air around us in the environment. There are some challenges to this, but it can theoretically be done. This will be the most thermo efficient solar heat engine you could ever hope to ever build. And with that, I hope you enjoyed this video, because there's a heck of a lot more to come. I promise you.